Welcome to the Agile Software Engineering Deep Dive, the podcast where we unpack the ideas shaping modern software engineering. My name is Alessandro Guida, and I've spent most of my career building and leading software engineering teams across several industries. And today I want to continue the discussion about Safe Light. In the previous article, I introduced Safe Light as a lighter way to scale Agile. Less ceremony, less centralized control, but still enough structure to make dependencies, integration, architecture, and release readiness visible. But there is an important question behind that idea. What makes lightweight scaling safe? The answer is not simply better planning, it is better architecture. Because if everything depends on everything else, teams cannot really move independently. They may look autonomous on an organization chart, but in practice they are blocked by hidden coupling, unclear ownership, unstable interfaces, and integration surprises. And when that happens, organizations usually respond by adding more process. More meetings, more reporting, more coordination, more governance. But often the real problem is not lack of process. The real problem is that the architecture does not support independent change. In this episode, I introduce evolutionary architecture as the technical foundation of Safe Light. Architecture planned for change, guided by clear boundaries, explicit dependencies, fitness functions, continuous feedback, and architectural guardrails. Because when architecture is weak, process expands to compensate. When architecture is strong, process can remain lighter. Let's dive in.
You know that feeling when you're driving on a massive 10-lane highway that was supposedly built for ultimate speed, but you are just completely stuck in gridlock?
Oh yeah, the classic phantom traffic jam.
Right. You look around and there aren't any accidents. The weather is, perfectly fine.
It's just inherently poorly designed.
Exactly. Every time someone tries to merge or exit, traffic just backs up for miles, and you're sitting there being told you're agile, you're supposed to be moving fast, but instead you're just sitting in bumper-to-bumper traffic.
It's a brilliant illustration, really, of how a system's underlying structure dictates how fast you can actually go, regardless of what the speed limit signs claim.
Yeah, and that is exactly what we are unpacking in today's deep dive. We're pulling some amazing insights from issue 33 of Alessandro Guida's Agile Software Engineering newsletter.
It's a really fantastic piece.
It is. The piece is called Safe Light Part 2, Evolutionary Architecture. And our mission today is to show you, the listener, a counterintuitive truth, which is fixing a broken Agile process doesn't require more process.
Right. It requires better code architecture.
Yes. And before we get fully into the weeds here, I want to say, if you want more insights like this delivered straight to you, make sure to go read that full article and hit subscribe on Alessandro's newsletter. And, hit subscribe on this deep dive too, so you don't miss our future breakdowns.
Yeah, it's highly recommended reading, especially if you're currently trapped in a cycle of endless alignment meetings.
Yeah.
Because that's the core pain point we're dissecting today.
The dreaded alignment meeting.
Right. Organizations adopt these really heavy scaling frameworks like SAFe, the Scaled Agile Framework, hoping to coordinate dozens of teams.
But they quickly realize that teams aren't actually autonomous at all.
No, not at all. They get bogged down in dependency boards, release negotiations, escalation paths. It just becomes pure coordination theater.
Coordination theater. I love that term. I mean, I'll admit, when I look at a calendar full of alignment meetings, my first thought is usually, okay, we clearly have a project management problem.
Sure, that's the natural assumption.
But the argument here is that the calendar is really just a symptom, right?
Exactly. When architecture is weak, process expands to compensate for it. But when architecture is strong, your process can remain so much lighter.
It's like putting a massive Formula One racing spoiler on a broken down minivan.
That is a perfect way to describe it.
You can add all the Agile ceremony you want. You can have the most colorful dependency boards in the office, the most rigorous daily stand-ups. But if the underlying engine, the code base architecture, is tied in knots, you aren't going fast.
You're just holding more meetings about why the minivan won't start.
Yeah. But I have to push back a bit here because let's say an organization does have a tangled mess of code. Everything depends on everything else. Is a concept like Safe Light, or really any lightweight agile scaling, is that even physically possible?
The short answer is no. It's really not.
Wow, okay.
Because if your team boundaries don't match your architectural boundaries, every single feature you try to build becomes this massive multi-team negotiation.
So it's a structural barrier.
Yeah. Let's break down the mechanics of why. Imagine Team A wants to add, I don't know, a simple checkout button. But that button touches a database schema that's owned by Team B.
Okay, pretty common.
And then to reach that database, it has to route through a legacy API managed by Team C.
Right, so you can't just sprint on that. Team A is immediately blocked until Team B and Team C adjust their sprint backlogs to accommodate the change.
Precisely. The system itself generates the friction. The architecture actively resists independent progress. And that is why any form of lightweight Agile absolutely requires evolutionary architecture.
Okay, so if weak architecture is the disease, evolutionary architecture is the cure. But I'll be honest, evolutionary sounds like, well, one of those buzzwords executives throw around when they don't actually have a plan.
Yeah, I hear that a lot.
Isn't emergent or evolutionary architecture just a fancy excuse for letting developers code whatever they want and just hoping a cohesive system magically appears? Because to me, that sounds like drift, not design.
Right. And that is a dangerous, albeit very common misconception. What you are describing is architectural entropy.
Entropy, okay.
Drift happens when technical debt becomes normalized. It's when a developer, say, bypasses an API to read directly from a database just because it's faster for their current ticket.
Oh, yeah. We've all done that.
Right. And suddenly, data ownership is completely murky. Nobody is quite sure if a change is safe, and every deployment becomes this terrifying gamble.
Yeah, you tweak a CSS class for the checkout cart, and somehow the email newsletter system crashes.
Exactly. And that happens because of unmanaged drift. Evolutionary architecture, by stark contrast, is intentional. It's heavily guided.
Guided how? Exactly.
Well, it means the software is explicitly designed for incremental change. It allows teams to learn, adjust, and refactor continuously, but they do so within deliberate constraints.
So the system doesn't just collapse into accidental complexity.
Right. And the mechanical way we guide this evolution is through something called fitness functions.
Okay, fitness functions. Are we talking about standard unit tests here? Because I feel like, every team already runs automated tests to see if the checkout cart totals the right amount.
No. Fitness functions are fundamentally different. While a functional test checks user behavior, a fitness function is an automated test for your architectural rules.
Oh, interesting.
Think of it less like a behavioral check and more like a structural spell checker for your code base.
A structural spell checker. I really like that. So what exactly is it checking for? Walk me through the actual mechanism of that.
Okay, let's say your architectural design dictates that the user interface should never, under any circumstances, communicate directly with the backend database.
Makes sense.
You write a fitness function, which is basically an automated script, that analyzes the code structure itself. If a developer accidentally writes code that creates a direct dependency between the UI layer and the database, the fitness function fails.
Whoa.
It runs in your integration pipeline and literally blocks the build from being deployed.
Oh, wow. So it physically prevents structural drift from even entering production.
Exactly. And you can write fitness functions for all sorts of things. You can have tests ensuring that API response times stay below a 200 millisecond threshold.
Or like security stuff.
Yeah, you can have automated checks that guarantee developers aren't importing forbidden, highly vulnerable third-party libraries.
And here is why this is so critical for you, the listener, especially if you are tired of being bottlenecked. These fitness functions act as a form of lightweight automated governance.
Which is huge.
Yeah, think about the alternative. In a traditional corporate environment, to ensure code meets architectural standards, you have to, submit your design to an architecture review board.
Oh, the dreaded ARB.
Right. You sit in a room for 3 hours, arguing with the committee, just waiting for manual approval. Fitness functions take that human bottleneck entirely out of the equation.
They do. It makes change inherently safe, which means it makes change fast. It only stops developers when they are about to damage something structurally critical.
Okay, so the fitness functions automatically enforce the rules, but what are those rules actually trying to protect? From what I'm gathering, the ultimate goal here is protecting boundary.
That is the core of it, yes. Evolutionary architecture isn't about drawing the prettiest deployment diagram.
Right.
It is entirely about the capability to change safely over time. And a massive system cannot evolve safely if a change in Module A forces a complete rewrite in Module Z.
Yeah, that's a nightmare.
You need strict, non-negotiable boundaries.
Because if you have those boundaries, Team A can own their module, completely rewrite their underlying logic, and deploy it to production without ever needing to coordinate with Team B.
Exactly, as long as the public-facing API doesn't change.
And that is true autonomy. But, discussing boundaries immediately brings us to the elephant in the room, microservices.
Right.
For the last decade, I feel like the industry has treated microservices as the silver bullet for scaling agile teams. Like, the conventional wisdom is if your monolith is a tangled mess, just chop it up into 50 microservices, give one to each team, and boom, you have perfect boundaries.
Yeah, if only.
But I'm guessing it's not that simple.
It is absolutely not that simple, and it's a trap so many organizations fall into. Microservices can support evolutionary architecture, but only if they represent true, meaningful domain boundaries.
Okay, meaning what exactly?
Well, if you take a confused, deeply entangled monolith and simply slice it into microservices, you haven't actually fixed the architectural confusion. You have merely distributed that exact same confusion across a network.
Oh, I see where this is going. Instead of a single tangled ball of yarn on one server, you now have 50 tiny tangled balls of yarn.
Yes.
And worse, they all have to talk to each other over HTTP.
And that introduces catastrophic operational complexity. When components communicate inside a monolith, it's just a localized function call in memory. It's instantaneous.
Right, it's practically free.
But when you distribute a mess into microservices, you are suddenly dealing with network latency, dropped packets, timeouts, massive deployment orchestration.
So if a user clicks buy, and that request has to bounce between 7 different microservices over a network just to complete the transaction.
Your performance will absolutely tank, and debugging an error becomes a total nightmare.
So a poorly designed microservice architecture is actually far worse than a monolith.
Much worse. Look at the real-world examples. Amazon and Netflix successfully utilized cloud-native microservices, but they did it by aligning those services with massive, highly independent domains.
And very specific team ownership.
Yes, their architecture, their delivery model, and their organizational chart all evolved together. The lesson from Netflix wasn't just use microservices.
Right.
But look at the flip side. Look at Shopify.
Shopify is fascinating here because they completely rejected the microservices trend, right?
They did.
They handle a staggering amount of global e-commerce traffic, yet they invested heavily in a modular monolith, specifically using Ruby on Rails.
Exactly. Shopify proved unequivocally that you do not need microservices to achieve an evolutionary architecture. You simply need clear internal boundaries.
So it's still one big code base?
Yes, in a modular monolith, the codebase is still deployed as a single unit, but the framework strictly enforces logical boundaries. The billing module cannot physically access the inventory module's database tables. It has to go through an internal, clearly defined interface.
Okay, so they get the clean team boundaries and the independent development of microservices, but without the terrifying network latency and deployment nightmares.
Exactly.
It's a brilliant reminder that architecture should evolve toward better changeability, not just toward whatever deployment style is currently trending on tech blogs.
Precisely. You optimize for safe change, whatever the deployment vehicle is.
All right, this is all incredibly logical if you are starting fresh. Like if you are building a pristine greenfield project today, absolutely draw those beautiful boundaries, set up your fitness functions, choose your modular monolith.
Sure, in an ideal world.
But let's be real for a second. What does this mean for someone listening right now who is drowning in a 10-year-old legacy code base?
Yeah, the reality for most developers.
Exactly. I'm talking about a massive system where the original developers left 5 years ago and nobody actually knows how the core transaction engine works. Do we just have to bite the bullet, burn it all down, and do a massive big bang rewrite?
No, please don't. In fact, large-scale rewrites are incredibly dangerous.
But they're so tempting.
They are seductive because they promise a clean, beautiful future, completely free of legacy constraints. But mechanically, they almost always fail.
Really? Almost always?
Yes. They take years longer than projected, they halt the delivery of new business features, and honestly, because the organization hasn't changed its fundamental habits, the rewrite often just recreates the exact same tangled complexity.
Just in a newer programming language.
Exactly.
So if a big bang rewrite is off the table, and we obviously can't just leave it as a tangled mess, how do we actually fix a legacy system?
By focusing on a strategy called encapsulating volatility.
Encapsulating volatility. Okay.
The goal of evolutionary architecture is to identify the specific parts of a system that are chaotic or likely to change frequently, and wall them off behind strict abstractions.
Okay, so I'm guessing that means taking the unpredictable elements, like, say, a third-party payment gateway that updates its API every month,
Right.
or maybe a highly experimental machine learning model, and wrapping them in an internal interface.
That's the idea.
So when Stripe or PayPal changes their code, our entire TechAt system doesn't break. We only have to update that one isolated wrapper.
Exactly. You contain the blast radius of change. And you can apply this exact same concept to legacy systems using what Martin Fowler famously coined the strangler fig application pattern.
Ew, I know the strangler fig pattern from nature. It's like a vine that grows around an old tree until it eventually replaces it.
Exactly.
But mechanically, in software, how does that actually work? Like, if I have a giant legacy database, how do I strangle it without causing a massive data corruption issue where half the system writes to the old database and half writes to the new one?
That is the critical challenge.
Yep.
Mechanically, you don't touch the legacy database first. You start by building a new facade.
Like an API gateway.
Right, an API gateway or a routing layer right in front of the legacy system. All incoming user traffic hits this new routing layer. And initially, the router just passes 100% of the traffic straight back to the old legacy system.
Oh, I see. So to the user, nothing has changed at all.
Right. Then you build out a small single piece of functionality in your new clean architecture, let's say the user profile service.
Okay.
Once it's ready, you configure that routing layer to intercept any requests for user profiles and redirect them to the new service.
While the rest of the traffic still goes to the legacy monolith.
Exactly.
But what about the data? If the new profile service needs to read data from the old legacy billing system, how does that work?
That's where you build an anti-corruption layer. The new service communicates with the old system through a strict translator, ensuring that those messy legacy data models don't bleed into your new clean architecture.
Oh, that makes sense.
And then, step by step, endpoint by endpoint, you redirect traffic. The old system slowly shrinks as it receives fewer and fewer requests, and the new system grows.
It's just incremental modernization. You completely avoid that terrifying, dramatic cutover weekend where the IT team flips the switch at 2 a.m. and just prays the new system doesn't crash the entire company.
Exactly. The architecture changes dynamically while the business continues to operate normally.
And this buys your team's independence. You are physically removing the architectural bottlenecks one by one, which naturally reduces the need for all those agile coordination meetings we talked about at the start.
Absolutely.
Okay, so we've strangled the monolith, we've established clear boundaries, we have automated fitness functions checking our code. It sounds perfect. But I see a glaring human flaw here.
Oh, what's that?
5 years from now, our current engineering team is going to move on to other companies. A new senior developer is going to inherit this code base. They are going to look at our complex routing layer and our anti-corruption wrappers and have absolutely no idea why they were built this way.
That happens all the time.
Right. So how do we prevent future developers from accidentally ripping out our carefully evolved architecture just because they lack the context?
That is exactly why evolutionary architecture cannot survive without architectural memory. If a system is going to evolve over a decade, you need a robust mechanism to document the why. And we do that using architecture decision records, or ADRs.
Because honestly, every developer listening has had that moment of looking at 5-year-old code, throwing their hands up and screaming, "What idiot built it this way?"
Oh, countless times.
Only to realize, a week later that there was actually a really good obscure reason for it.
Exactly. Architectural decisions are rarely universally right or wrong. They are right or wrong in their specific context. A database choice that made perfect sense when you had 10,000 users might be a massive bottleneck when you have 10 million.
So what actually goes into an ADR to capture that context? Is it some huge wiki page?
No, it's a very lightweight, standardized markdown document stored right alongside the code.
Oh, that's smart.
Yeah, it captures the title of the decision, the status, whether it's proposed, accepted, or deprecated, the specific context at the time, the alternatives that were considered, and the agreed-upon consequences of the decision.
So when that new developer arrives in 5 years, they don't preserve an outdated routing layer just because they are terrified to touch it.
Right.
But they also don't blindly delete it without understanding the hidden dependencies. They read the ADR, they understand the original constraints, and they can make a highly informed, confident choice about how to evolve it next.
It enables what we call autonomy with alignment. Teams need the freedom to make localized decisions, choose their internal implementations, and own their modules.
But they must do this within shared automated rules.
Yes, our fitness functions.
Yeah.
And with shared context, our ADRs. The ultimate goal isn't central, top-down control. It is actively designing a system that makes independent progress physically possible, reducing the need for constant manual coordination.
And that leads perfectly back to our starting point about continuous delivery and observability because, theory on a whiteboard is one thing, but production is reality.
Precisely. Continuous delivery provides the automated machinery, the deployment pipelines, that makes this safe change possible. And observability provides the reality check.
Meaning what, exactly?
Well, you might design a service boundary that seems incredibly logical on paper, but when you look at your real-world telemetry, your logs, your latency trends, you realize it's actually creating a massive traffic bottleneck.
Ah, I see.
Evolutionary architecture demands that you observe those metrics, learn from the friction, and adjust the boundaries accordingly.
Which fundamentally changes what it means to be a software architect. To summarize everything we've unpacked today, safe flight, or really any attempt to scale Agile gracefully, isn't about just deleting meetings from your calendar and hoping for the best.
No, definitely not.
It's about keeping only the coordination that genuinely adds value and replacing the rest with architectural integrity.
The role of the architect shifts completely. They're no longer this ivory tower dictator defining a perfect static blueprint up front and policing compliance. The architect becomes a steward of changeability.
Their job is to ensure the system can bend without breaking. They help define the boundaries, they establish the automated fitness functions to catch drift.
And they ensure decisions are captured in ADRs.
Right. They remove the structural friction so the development process can finally move as fast as Agile promised it would. It's a profound shift in thinking. It's moving from trying to predict the future to building a system that can gracefully absorb whatever the future throws at it.
It really is.
Now, if you want to dive even deeper into these concepts, and trust me, the mechanics here are fascinating, we highly encourage you to go read the full article in the Agile Software Engineering newsletter. It's issue 33 by Alessandro Guida.
Yes, highly recommended.
Be sure to subscribe to his newsletter for a masterclass on engineering leadership.
It truly is essential reading for anyone trying to bridge that frustrating gap between Agile delivery and long-term technical health.
And hey, if this deep dive gave you an aha moment today, or if you finally understand why your microservices are driving you crazy, please subscribe to our deep dive, leave a review, and share this with your team.
Yes, please do.
Because honestly, the more people who understand these architectural boundaries, the fewer useless alignment meetings we all have to sit through.
Which is a win for everybody.
Absolutely. Before we go, I want to leave you with a final provocative thought to mull over. We spent this entire time talking about using fitness functions, these automated structural tests, to stop our code architecture from degrading into chaos. But it makes you wonder, could an organization create organizational fitness functions?
Oh, that is a fascinating concept.
Think about it. Could you build automated triggers or metrics that test if your meetings, your approval processes, or your Agile ceremonies are slowly degrading into useless bureaucracy?
Like an automated script for corporate bloat.
Exactly. If a meeting regularly produces no actionable outcomes, does a script automatically cancel the recurring calendar invite? Think about how you might systematically test your own calendar for entropy.
I love that idea.
At the end of the day, you don't want to be sitting on a 10-lane highway wondering why you aren't moving. You want to fix the on-ramps, build better boundaries, and actually get to where you're going. Thanks for joining us, and we'll see you on the next deep dive.
Thank you for listening to the Agile Engineering Deep Dive podcast. If you found this episode valuable, feel free to share it with someone who might benefit, a colleague, your team, or your network. You can access all episodes by subscribing to the podcast and find their written counterparts in the Agile Software Engineering newsletter on LinkedIn. And if you have thoughts, ideas, or stories from your own engineering journey, I'd love to hear from you. Your input helps shape what we explore next. Thanks again for tuning in, and see you in the next episode.